Alright, me again. Yeah, graph science. Physics, of course. And we're going to get to whatever that guy is, the photographer guy. The, whatever he is, the angry Theodora Apophasis. Anyway, he's doing this ferrofluid stuff to show magnetism. And, he's revising his book consistent with these new and improved images, so to speak. Anyway, this is the old video. Here's the new book video. This one. So this one I think is a moving thing. I don't know. So you're not really explained what this exactly is, but it does this, whatever, revealing of, the magnetic force lines. I just thought I'd talk about that a little bit because it's sort of interesting. The ferrofluid. The Wikipedia page isn't too great, but there are some great images. In a Google search, and I found this one particularly useful. The fluid's made it's this whole nanotechnology thing. You make something. The regular ferrous fluid, the regular ferrous particles, they're a little bit too big, and so they stick to each other, and that kind of screws the whole image thing you get. So you don't get as clean a line because they're actually little magnets and they stick to each other and they sort of mess up the game. But with this fluid and little tiny bits in the fluid, you can get more interesting things rise out of the fluid, so to speak, in terms of more revealing of what's happening. So anyway, these little peaks are really the important thing happening right here. And theoretically, I guess I would argue that if they could do this in space or something in free fall, where gravity isn't mucking the game, these little spikes might get quite long, and theoretically they would just do exactly like a field line. They go from, so they say this is the north side of the magnet, and they would do exactly the around the horn, so to speak, like threads. And that's really what they're trying to be, is as small as possible. They're trying to be a little thread. And the thing to really understand is this is really a consequence of the place where there's no force. As funny as that sounds, it's where the force is balanced. And so the thing doesn't have to go anywhere. It's comfortable. So once it gets there, it'll stay there, theoretically. So the idea would be, is in space you could mix this fluid, and theoretically it could perhaps maintain the structure of these field lines without gravity, more force, breaking them, knocking them down, because they just don't have enough strength. They're just a neutrality, and any external wind will destroy them because it's a place of neutrality. And so there's no force holding them there. There's the absence of force is what's holding them there. Funny as that sounds, the absence of an imbalance. So there's nothing imbalanced in these. Theoretically, this little thread's coming up here, and all this is just clinging on, and gravity's, doing its job to push it down, but it's all trying to get to that thread. It's all just trying to get to that center. Because it's in a place where the force is imbalanced, and it's so the idea of a magnet is that maybe I'll load one of these other images. Is that the field lines are really just a representation of where when the forces, all the little particles are only revealed because they themselves have turned into little magnets, and so they're trying to align with the most neutral position they can be at with this thing. So the idea is that the magnet's producing from one side this repulsive polarization, from the other side the attractive polarization, and inversely, the magnet, one side of it's attracted and one side of it's repulsed, and so it's trying to get into position where ideally the repulsive end is away and the attractive end is towards. So that's sort of like what happens when a magnet flips. Here the magnet's going to point because the force is coming out in straight lines here. Okay, it's radiating out. And these places are places where there's neutrality. So the point would be is that the lines coming out, like say this direction, what that represents is a neutrality between the mixture of these two polarizations. So it's the magnet's essentially trying to orient itself in a position where it's neutral to both, where both are satisfied with the condition, in the sense that it's getting, the tail's getting pushed as little as possible. If the tail moves up a little, it gets pushed more. If it moves down, it gets pushed. The head, so it's just lining up with the balance of the two forces, and that's the angle with which there's the least amount of pressure to move in some direction based on repulsion or attraction. And ironically, I guess I'm just trying to say is that these field lines aren't a representation of where the energy is. They're a representation of effectively where there is balance, and the rest of it is where there's imbalance. The white space is the imbalance, the dark space is the balance, kind of. So anyway, I think that's sort of an interesting feature. So anyway, this ferrofluid is essentially what the other guy's talking about. You know, they're using it now in a clear suspension. So, well, clearer. Like these suspensions are usually quite dark. They're always like black or something. And so apparently they can do this with clearer suspensions where, you know, this ferrous material, there's little nano bits of magnetizable element, are suspended in a clearer suspension. So I didn't find too much of that around yet. And what the idea is, they shine LEDs through two glass plates with fluid in between them, and then you get a reveal that's more than just a one-dimensional. It has a three-dimensional kind of effect. And I'm thinking it's a lot of distortion, personally. I'm thinking that's what this is reading. I mean, but this is really just the field lines. But the idea is you can see them as the actual lines. So anyway, this guy, when he's talking about this stuff, you know, I don't want to say he's being deceptive. Yeah, I don't want to say it, but, you know, it's sort of, I mean, the language is just kind of useless. You know, hyperboloid, torus, blah, blah, blah. And so I'll play this end of the video because he's just, you know, he just goes on an insane amount of jibber jabber, and I just don't think it's very useful as an explanation of anything. So anyway, this is an image he's using. It's not his image. His image is the other one's not quite as clear as this, but the idea is there's light coming in, and what you're seeing is where the fluid condenses. So this is where the little magnets line up, and you're seeing the light reflecting off of the impurities in the fluid. So these are the impurities in the fluid lining up, and this is supposedly the magnets north-south. And so I'm thinking these effects are distortions. These are visual distortions based on the glass and the fluid it's lensing or whatever it's doing, but I don't think these are representations of anything constructively revealing about the real mechanism. And all these lines in the back, these are all just crossovers. I mean, these are, because of the dimensionality, because this has a thickness to it, there's lines being that are behind and in front of, and they're all a little bit translucent, and so they're, you know, they magnify, and you can see the little nodules almost like little, because that's where there's twice as much brightness, because the one behind is lit and then the one on top is lit, and you're adding up the two light values. So that it's clearly these are, you know, there's a dimensionality to this, and this would be, say, the poles, and these lines are really coming up and down and around and up and down and around, and I don't know why it's coming out looking like this. I mean, this isn't terribly, I don't think it's a reveal of the actual structure, but what it's really great for is the idea of how these lines are really thin in their, they wish to be very thin. The neutral space is a very thin little place where there's the neutral, and again, these lines are not, it's the stuff moving. The stuff is actually moving perpendicular to the lines. I mean, the force is actually coming out in rays, and these rays create points where there's a complete balance of force. Like as much force is coming from one place as is from the other place. So the attraction and the repulsion is completely balanced. There's as much of the magnet is repulsed as it is attracted, and it's stuck, so to speak, in a place where it doesn't need to move because everything's comfortable. The tension in the magnet is equalized, and therefore it doesn't move because the tension is already equalized between the two poles. I don't know how exactly to say that, but anyway, these are the neutral. Like I said, these are a representation of the neutrality. And again, this relates to this, so many things, because this sort of does reveal, in a sense, the two-slit pattern. The idea of these lines, it's the same kind of, regular, what's imposed. So I don't know if there's anything else I need to say on that, except his description is not very descriptive. This doesn't really explain how the force works. It doesn't do any of that. He just goes on about this much more complex mechanism inside here that's generating something. And all that's really being generated is gravity goes in, gravity comes out. The field energy goes into a magnet. The field energy comes out, and it comes out polarized. It comes out different from one end to the other end. The south end is polarizing this way, and the north end is polarizing this way, and the materials themselves are, on the north end, more vulnerable to polarization this way, and then the south end more vulnerable to polarization that way. And so it's just a gravity amplifier. That's all a magnet really is, because it's sensitive to polarization and it's creating polarization. Okay. Those are the two things you can be in the magnetic world. You can be sensitive to polarization like a piece of steel, or you can be producing polarization like a conductor with electricity going through it, or a magnet. All right. Yeah. So this is sort of, I've also been thinking about gravity again, and so I think, well, I'll play some of this and then I'll move on to that slight discussion. I don't know if it's really related to this, but it's all related, right? It's all the same subject, really. Gravity and its different manifestations. Quanta, the kinetic universe, kinetic quanta, and its different manifestations. That's all this is.
Spatial geometry, the divergent reciprocating processional hyperboloid that defines magnetism.
So, I can't even remember what he said. The progressional, geometric, progressional, trapezoid, I can't even, what? Really, I just don't see anything productive in this. Having a conversation in this manner as an explanation, you might as well just say woo, 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 woo. Because, yeah, what? How does that make one thing run into the other? How does that make one magnet repel another?
Is irrefutable. There is nobody on this earth that can deny it. They can chirp as much as they like, but...
Okay, well, I'll chirp a little. See, this image, I think, is just a little deceptive. Like I said, we don't know what this is, but this isn't just a magnet when this is what happens. There's some structure here or something. And, again, clearly the hand can be seen. There's no real distortion here in the image anywhere else. But again, I can't explain this surface defect in the sense that what's happening in here, maybe we can only see things that have an angle to the light source. So anything going, let's see, what's the right way to say it? Anything that it has to reflect down off the top of something. It can't bounce off the other side of the material. So you're not seeing refractions coming up. You're seeing ones that first have to, it's like the light has to be hitting on an angle and then bouncing back out. And so you're not seeing the parts like this would branch down this way, and this would be coming out of this way. And you're not seeing this part of it. It's like they fade out here. They fade out and they fade out and they fade out. So I think that might be part of the misrepresentation, is you can't quite tell what direction these might be coming from, but they might be doing that kind of thing. So it's kind of hard. I mean, I don't have a debunk. I'm just saying that we know from other examples of these, fluid reveals, that this pattern is more complicated than that. No, it'd be interesting if they can make this fluid thicker and then, have a tube through it, so you can put a magnet inside the tube and then see what happens, inside a broader thickness of fluid. But again, I don't know what this, like I said, this might be a spinning device. Who knows? We're not given any information.
But it is without refutation. Here is a more accurate view of the toroid of the divergent. Of course, here we have in the center that defines the negative image, if you will, analogously, defines the toroid. And of course, as is the case with all branches of physics and metaphysics, we have a positive that defines a negative and the negative that defines a positive.
Which isn't really saying anything again. But the idea that this would be spinning clockwise and this would be spinning counterclockwise, kind of an idea, blah, 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 that sort of has some sort of okay, sort of, kind of. But, clockwise and counterclockwise, I was thinking about it today, spin in general. Spin is a neutralizer. Spin is conservation revealed, in a sense, because you have this, you have a motion down and you have a motion going up. You have a motion left, you have a motion right. It's completely conservative. It's again one of these balance things. In and of itself, it has no. It's balanced. It's producing what it's consuming, in a sense, and it's only when it's mixing with something that's not spinning. Let me think. What's the right way to say that? Something that's in some sort of other condition. Yeah, I don't know. I have to think on how to say that correctly. But the mechanism that's creating the tension between a spinning object and a non-spinning object is friction. I mean, without the bonding element, the elements that forces the one surface to become a spinning surface, that's when it all breaks down. That's when you start seeing a reveal of energy. And the reveal of energy is because the two things are being obliged. You're stealing energy from the spinning wheel, in a sense. You're breaking its conservation. So when a wheel spins in friction, you spin a wheel and put it on a surface and it moves, then you've lost your conservation because of the friction. Okay. Obviously the spin is reduced. The speed of the spin will be reduced unless there's some engine producing it by the friction.
What gives definition to the toroid is the negative image here, which is the hyperboloid. This central portion right here, which is demarcated in this hourglass formation. So we
see, his own drawing is a little bit lame in the sense that the idea is supposed to be that this toroid is really an inverted sphere. So the idea is that you would have the toroid would go all the way to the center of a circle, and then if you unfolded the toroid all the way around, you'd end up with a sphere. It would cover a sphere, but it would have to be a toroid that has this. You have to have this kind of angle, and obviously this angle is much too short. So theoretically, this angle should be way up. His orange angle should be up here, not here. Theoretically.
When we think of a donut shape or a toroid, we obviously have that picture in our mind. But what gives definition to that spatial denotation of a toroid?
Spatial denotation of a toroid. I just don't. Sorry. I mean, you don't talk about photography and you don't do this. You don't. You don't use this many obtuse words.
Is the counterspatial inertial?
I mean, counterspatial. I mean, you just can't just say something like counterspatial. I mean, it just doesn't say anything. What's a counterspatial? What? Placenta?
Hypergeometry, which technically is a term, by the way. The hypergeometry.
Well, I mean, it is a term, by the way. Yeah, I don't know. Is it really one that anybody has a definition of? Hyper.
Which is the non-Euclidean inertial non-spatial component, which gives
the non-spatial component. I mean, what, you know, again, where do you, what am I supposed to make of non-spatial component? You mean non-existent? You mean existent but invisible component? The magical component? I mean, again, you're just, this isn't demystifying magnetism. This sounds more mystical than a Feynman explanation. I mean, you mock Feynman, but I mean, this sounds, if Feynman said this shit, everybody would be like, what the fuck did he just say? What is he talking about? He just made all that crap up, right? I mean, virtual particle is a lot more understandable than this. See, and that's where, you know, I would argue that Feynman is kind of correct. See, because what Feynman's basically arguing is that, you know, when this magnet is producing, it's producing these rays. Those are his vertical, those are what Feynman would argue are the virtual particles. They're the force. They're the thing, you know, the virtual particles, the virtual photons, sorry, are the ones flying out of this magnet as force. And the forces are polarized. You know, they're two different kinds of force, and the entities are always going to have that polarization revealed, right? I mean, you know, I think Hothloday made some comment like, you know, explain why when you cut a magnet in half, it, you know, regains its polarization. Well, that's just because one end is already polarized. So no matter where you cut this magnet, you'll be cutting it, and the hard polarization of one end of it is still going to exist, and it's going to just repolarize to that. But you can obviously change the polarization of ferrous magnets, right? You can demagnetize and remagnetize in a new in the opposite configuration. So obviously it just has to do with switching, you know, flipping, you know, something upside down or right side up, clockwise spin versus a counterclockwise spin, you know, that kind of thing. Okay, so back to toroids.
The definitions of the toroid, which is the hyperboloid. This is irrefutable.
Yeah, so, right. It's irrefutable, undeniable, whatever. This toroid thingy. So he doesn't go with these lines, these centric lines. He says that's not correct because he's arguing that there's a tornadic. These lines don't reflect the real. I mean, they should just get rid of this grid work and just do it all in these colored lines. That would be his argument, I think.
It is simplex pressure dynamic mediation.
Simplex pressure dynamic mediation. Dynamic pressure mediation, maybe. But anyway, what?
In its most absolute sense. And there is no higher absolute in referring to this because it is the most fundamental.
It's the most fundamental and absolute. It's fundamentally absolutely. It's absolutely fundamental. Well, this, as an absolute fundamental, I'd say, is a long way from being a cognizable, a mentally coherently understandable model of reality. So I think the idea of a field of quantum directional bits makes a hell of a lot more sense than this.
Mental nature of the universe, and that is magnetism, because it is what gives definition to 100% of spatial volume.
Well, you know, I think that's an exaggeration. So it's critically important. Polarization of quanta is important. I think it's really important holding atoms together and all this stuff. But the idea of the quanta existing in the first place is even more fundamental. The idea of direction existing as an element, and the fact that you can absorb direction and then gain velocity, that you maintain your velocity because it's actually something you've actually absorbed. It's a physical entity, little things, little Pac-Men, all moving in the direction that you're moving. And you'll keep moving the way they're moving until some other Pac-Man invade you, exchange places with those Pac-Man, and now become your new identity. But that's what you are. You're full of little bits, little Pac-Men who have a direction, and they always go where they're going, and it's only when you have to exchange, you have to bang into one of them, and then you take its direction and it takes your direction, And that's the nature of all of the condensation, the nature of the pressure. The pressure is there's a bunch of Pac-Men that are coming right for me. Right now there's little stars in space, and 15 billion years ago a photon left, and it's a little Pac-Man. And that little Pac-Man come all the way across space. Well, and it banged into my roof. But the idea was it was heading right for me. Right? It was heading right for me. And the whole universe is doing that. It's heading right for you. But it's heading right for every space in space. Every space in space has a bunch of shit heading right for it. We're all targets of the pressure.
That we see, feel, and touch, witness across the galaxies and beyond.
And beyond.
This is likewise seen in accretion disk formations, seen in galactic jets.
Accretions, secretions. Yeah, I secreted a few things that look like that, I suppose.
This is seen in spiral galaxies. From macro to micro.
I don't know. This is exactly what you see in a spiral galaxy. Like I said, you don't see this anywhere but in your device, your toy. And so you got to wonder, you know, is that reality or is it something else? Does it have a little bit of lens flare?
Oh, everything is self-similar. It is all
everything is self-similar. What is that? I mean, I just don't understand. I'm sorry. But if I said self-similar, if I said it in any context, I can't even imagine a context where I could say the words self-similar and somebody would know what I'm talking. I mean, peas and corn are self-similar. What? I mean, I can't relate it to anything. I can't talk about a single thing on planet Earth that I can imagine at this moment. I can't think of a single way to possibly use the phrase self-similar. It's not words. It's not a proper concept.
complex fractal pressure dynamic mediation.
Yes, pressure I get. Mediation, I just don't know what's the point of that one. Mediation? I mean, the universe doesn't look like mediation to me. It looks like fucking explosions and fires, and it looks like a lot of not mediating. A very hard compromise.
But understanding the spatial counterspatial geometry that defines magnetism is somewhat obtuse, and most human beings are certainly not inclined to think in those sort of terms. Here we have...
Yeah, well, this, again, this is a little better, in terms of this part's a little fuller and more complete. And then you get this idea of this whatever coming out of here and this whatever coming out of here. But like I said, we already kind of know that these lines aren't doing that. These lines are doing this. That's a rather complete, non-rotating. The field lines aren't twisted. So, this idea that you're claiming a twist, well, why isn't it revealed in any of these other experiments? Why aren't the same field lines representing or revealing themselves in that manner? Why does every other experiment reveal them differently?
Of another hyperboloid, and obviously...
I mean, clearly, if I took a piece of paper here and put a piece of paper here with iron filings on this side, I'm not going to get spiral lines this way. I'm going to get field lines this way.
The divergent reciprocating magnetism that also persists.
I mean, again, understand that when he's doing this, when he's creating these lines, these are photons being bounced off of substance. This is where the substance has aligned itself. This isn't a reveal of where force is going. This is a reveal of where substance is aligning.
This is at a frequency that defines the toroid. So the ultimate point of this is that the toroid and
I mean, I didn't want to imply that that was a real image. Obviously, that's just a computer-generated junk. But I showed you the real thing. It is interesting, but I'll just play a little more of this.
Hyperboloid are both one and the same thing. You got one side of the coin and then the other side of the coin, but they're both the coin. They're both one and the same thing. One is the hypergeometry and the other one is the spatial geometry. It is so simple.
Right, hypergeometry and spatial geometry, and then you use the phrase, it is so simple. I'm just being honest. I'm just saying, look, I'm trying to understand what you're talking about, but that doesn't sound so simple. I mean, you go ahead and call me an idiot. You can say, well, you're too stupid. I don't think I'm too stupid. I'm just I'm just saying this doesn't really do it in terms of explaining, besides just saying, well, it's just magically delicious. It just magically causes attraction. Oh, magic then. Oh.
Mother Nature is so simple. She does not do math. She's not a cross-eyed crack whore with a bag full of magic particles. The universe is...
Well, whatever. I mean, obviously the universe does do an awful lot of math in the sense that the relationships that exist are relationships. They do exist. They're a fact. You know, geometry is a fact. Yeah, I mean, these are real relationships, real laws even, of the dynamics of energy in the universe. It follows rules, and those rules can be described mathematically. Now, I say there's a lot of excessive mathematics and fudgy mathematics. I mean, mathematics that just kind of reduces everything, to something more manageable. See, there's a million of these little lines, right? And so, yeah, you can have mathematics that just takes the averages, and so then you have to multiply 100 things instead of multiplying 1,000,000 things. So that kind of shortcuts, and those aren't terrible. They're not a crime, but sometimes they can be. I mean, too much simplification gets you in trouble.
Far, far, far more simple than your quantum physics class would ever have you believe. Simplicity is divinity.
Well, I don't even know what that means, but you see, here's another one of his round magnet ones here. So maybe we'll try that video real quick. Yeah. But there really wasn't anything simple there.
That crazy guy again that says there's no such thing as magnetic attraction.
Yes, dear, he's quite crazy. Yes, crazy like a fox.
Oh, he's doing TV this time.
A quick little demonstration, one last thing, and show you a neat little trick. Yes, more fun with CRT tubes.
Right, so this one's just
electrification.
Okay, so this one wasn't the fluid. This is the doing it with the electron gun. Yeah, screwing with the electron gun and a magnet, very powerful magnet. But anyway, let's see if we jump ahead. See if it will. Come on, YouTube. I hate that little spinning wheel. Centripetal, whatever that is. The centripetal. Progressing clockoid. I hate that fucker. I think it should be arrested and thrown in jail forever. Bastard. Okay, so there we go. See, now these are obviously now, these would be the field lines, right? I mean, it's sort of seeable here. Here's the north, here's the south. But, there are some distortions here, obviously. So again, when you three-dimensionalize, you end up with distortion. And so, yeah, I don't know whether how valuable that is. But I mean, this is the real deal in the sense that these are representing, and here you have your red and green again. Here, I don't know exactly why that would be. But obviously it has to do with the orientation, of the, what's being turned. I'm just looking. Oh, yeah. It's probably the fact that magnets sort of do have faces. I think these would have to be all lined up in the same direction, and that these are just I don't know. I think it's just an artifact of the three color pixels, because obviously the blue's in here too. So I'd have to think about that. I mean, it's obviously distorting the electrons coming from the electron gun. So, I mean, the gun is already magnetizing to make the electrons scan across the screen, and so it's fucking up the scan by pushing the electrons out of their normal place. So that's the red, orange, and green are probably just artifacts of that circumstance. Yeah, but it is clear that this one side it's green red, this side it's red green. So that's This side is green-red. This side is, it's also green-red. That's a little bit interesting. So green is on top on both these sides, the poles. Oh yeah, and so that's obvious. If you bend it this way, the orange goes on top. If you bend it that way, the green goes on top, of course. Yeah, so that makes sense. So anyway, enough of that. We'll move on. I just want to do a quick thing on gravity. I was thinking of an experiment. There's another one of these things where people say, non-falsifiable and all that kind of stuff. But this one would be testable. You need a satellite to do it, but I think it's testable. So anyway, I was thinking about gravity. All right. So here was my dilemma. So you got these two objects, and the problem is that distant objects. My argument is, right, that gravity is moving the speed of light. So distant objects, it's going to take a long time for the gravity being caused by this, by it accelerating. So again, I'm arguing that gravity only really exists when something is accelerating. If it's not accelerating, it's not producing what you would call gravity. It's not absorbing direction, so therefore it can't be denying direction, right? So if these two bodies were frozen in space and they couldn't move, so let's say they wanted to, but they couldn't, and they can't absorb force, then what happens to them is, see, obviously if you're holding them, then you're going to be applying force. Okay, so that's going to screw up the game. But let's say there was some magical thing that could hold them in place, even though they wanted to be attracted to each other, without applying a force, without changing the force dynamic. Well, the idea is that gravity is caused because there's a bunch of little quanta going this way, and what happens is as this acquires velocity, that means as this accelerates and gains speed, it's absorbing these Pac-Man, the Pac-Man going this way. Okay, maybe I'll use Pac-Man as the new metaphor. The Pac-Man going this way, it's absorbing, and so it eats a few of those. It takes them and gives back ones going this way or going the opposite direction, let's just say. And so that's it exchanges. It exchanges for the ones it's got for these ones going this way, and so it becomes heavy with these and light with the ones going in the opposite direction. And the point is that so as 3 go in and only 2 come out. And so this body over here, this one just like this one has the same force from the universe, 3, right? So it has 3 going this way, and now it's only getting 2 from this side. So only 2 are coming in this way. So it has a deficit, and that deficit's going to be realized in the sense that more of these are going to change this thing than those. They're both changing. They're both trying to change this identity. Obviously, the one with 3 is going to do more changing than the one with 2, and that means this thing's going to acquire velocity in this direction. All right, and as it does that, it's obviously going to eat some of these arrows. So only 2 of these arrows are going to come out now. So now this side's going to get induced again into moving. So the two things are inducing the gravity. Now the problem with that is, obviously, well, if it takes, let's say, 10 minutes to get to Saturn or something from the sun. So let's say this is the sun and this is Saturn, let's just say, or whatever, Uranus or something. The problem is this thing is moving this way too. So it's, in 10 minutes, it's going to be over here. So let's say it takes 10 minutes for these two to get to the sun. So the sun's stationary, so this planet doesn't have any problem hitting the sun because the sun's not moving out of the way. But when the sun shoots it back, the gravity is going to be going here, and there's no planet here anymore. Planet's over here. So the gravity is not going to have any effect. And obviously, it occurred to me, that's obvious, right? Because that's why there's so little gravity out in space. So you see, theoretically, if it was instantaneous, then the gravity, like I say, the gravity on the surface of the sun is 617 miles an hour, per second. And out here, it's like 0.002 miles per second. It's really, really lame way out here. So that's the reason. See, if it was instantaneous, then all of the gravity would make it back to here. And all of the gravity created by this would make it to this planet. So this gravity would be 617 miles per hour per second. So it's the weakness of the gravity by the inverse square rule is really a representation of, as you move further away, light takes longer to get from where the source is to you, and that time delay is enough for you to miss your gravity. So as you get further and further away, the time delay denies you more and more of your gravity, and now you're getting less and less of it, because now you're really just getting the random bits going in this direction. So let's say a random bit goes this way, and this just randomly happens to absorb that arrow this time. And so now there's two arrows, say, going this way, and there's only one arrow going this way. Then this one will absorb the one extra arrow, and it'll move this way, and that'll induce the gravity. So that's a representation of, you're still getting your random amount of gravity, but you're not getting the gravity you induced, because the gravity you induced is behind you. Get it? So they're doing all this talking about gravity waves now, right, and finding them with their big expensive infirmometers. They're little mirror toys. But anyway, let's say they, what it really is just their idea is that these two things are spinning around each other, and the idea is that as they spin around each other, they're just going to call that a wave. This pattern of line. They're calling that a wave, and that's not really a wave, right? I mean, it's obviously some other mechanism is making that. And what it is an absence of force, the presence of force. More force, less force. More force, less force. And so the trick here is that I think what they'll be able to observe if they did this experiment. So this is the experiment I would propose. They send a satellite out in space pretty far, okay, past the moon, by some good amount, and then just measure as the moon goes around the Earth. Technically, the higher gravity should be behind the moon than at the moon. So you would say that these two bodies, by Newton, these two bodies right here would add up, and your strongest gravity would be here because this is the highest mass. But the point is the gravity this thing actually caused is behind it. It's shot here. And so ironically, or not even ironically, just by practical circumstance, the higher gravity is going to be behind the object. See, it still adds up to the same amount of gravity. So Newton's math still works. It's just the direction of the gravity is going to be a little bit different. It's not going to be when they're exactly aligned. It's going to be when they're a little bit off. And it's got to, it's going to be a close experiment just because, the moon's pretty close. I mean, it'd be better if the moon was further away, but, you have to do the experiment with what's available. And you're trying to pick up a gravitational difference, so you do need to have objects that are pretty big relative to the satellite size, and you have to be not too far away to detect that gravity. But I think it's a doable experiment. So in the future sometime they'll be saying, well, we have to verify that in random theory. This might be one of the ways to verify it. But anyway, I was struggling, by my theory. I have to account for how this gravity, somehow anticipates the velocity, the new position of the body when the gravity is being induced and it's limited to the speed of light. I mean, it's just not fast enough to create it. But, that's the funny part, is that if it did move instantaneously, then the full effect of the gravity, like a laser beam, would be exchanged. There would be no waste. The two bodies would induce full gravity in each other constantly, and there'd be no degrade because there'd be no scattering, no spreading, no missing. So really the diminishment in gravitational pressure as you move further away is proportionally related. This is by inverse square rule, but the inverse square rule is really a manifestation of the speed of light. And that's why light is controlled by the inverse square rule, because it's the same principle involved. The real limiting factor is the speed of light, and the fact that the speed of light is creating scatter. It's creating bad aiming. It's creating gravity that misses. And so the body's creating the same gravity, it's just missing. So the sun is being influenced as if Neptune was much closer than it is, but it's the gravity misses. So it would be interesting. So another experiment might be to have a body come up behind a planet and see if the gravity for that planet is stronger, because now it's been created. Essentially, Neptune created the gravitational field ahead of it. Yeah. Be interesting to see. Be like the opposite of drafting in motor racing. I would think there might be a circumstance where as you come up behind something, you're going to start getting deflected. So rather than getting locked into its airflow or locked into it, you then end up having a tendency to be pushed in front of it, to push, to be deflected at a higher angle than it's being deflected. So that's another experiment to do. That's hard to do because the only way you can reveal this problem is get far enough away where the speed of light becomes relevant. Which isn't that far away, technically. I mean, once you're talking about a minute, to get to the moon, right? It's like a minute or something. Back and forth. It's like 10 seconds, 15 seconds. You have 15 seconds to get there, and then 12 seconds to get there, 12 seconds back. 8 seconds? 8 seconds to get there, 8 seconds back, something like that. That might not be enough time to... Yeah, whatever. Okay, anyway, it solves my dilemma. As I was just wondering, like, how could there be gravity? And then I realized, I said, wait a minute, there isn't gravity. That's exactly the point. There isn't full gravity way out there. And the very reason there isn't is because the speed of light destroys it. The delay in transmission destroys the effectiveness of the gravity. It's hitting it's hitting empty space instead of the thing it's aiming at, so to speak. The thing that induced it isn't receiving it. This explains a lot of stuff, even in magnetism. This explains a lot of stuff that takes place in magnetism with speeds and harmonics, and why there's lag, and why something works better at a certain speed it runs perfectly smooth, another speed it wobbles all over the fucking place. All of that's probably explained by this very same phenomenon. So anyway, enough. So till next time and such, I think it's enough for now. No, I don't know. I'll post a link on this guy's. I'll post a comment on his video and see. I don't know what kind of comment. Like, I have a counter theory. Yeah, no, I have a few questions regarding what you're actually revealing with a ferrous fluid.